Welcome everyone to this panel discussion on real-world AI for supply chain planning, hosted by Slimstock. Today we're going to talk about the latest and greatest AI hypes in the context of supply chain planning. So today I'm joined by Pauly, research scientist at Slimstock, and Isik Bicer, professor of supply chain management at Schulich School of Business as part of York University here in Toronto. So welcome folks, thanks for being here with me today. Also thanks everyone on in the audience for joining us today. I'm going to talk a little bit about the agenda of what we're going to discuss today. So we have the following program. I'm going to introduce or let the panel introduce themselves for a minute. We'll do a short introduction of Slimstock. In the panel discussion, we're going to talk about basically four things: the different types of AI and machine learning that exist and their applicability to supply chain planning, actual and practical applications of AI machine learning, and new developments that have shown a lot of promising results, which might make their way to supply chain planning hopefully soon. We're going to talk about the relationship between AI machine learning models and supply chain design. And we're going to talk about, okay, what do you really need to do before you start using machine learning AI in your business? What are some of the requirements to get started with this? And we'll have some time for questions and answers at the end of the webinar, hopefully. So to get started with some quick introductions. My name is Danny Bloem. I'm an S&OP consultant and consultancy manager here at Slimstock Canada. I spend most of my career implementing and helping companies improve their demand and supply planning processes. Today I'll be the host of this panel. With me we have Pauly, research scientist at Slimstock. Steven, if you could take a minute to introduce yourself and why you're here today.
Yeah, sure. Thank you, Danny. So I'm Pauly from Belgium, working for Slimstock for almost 10 years now, I guess, and passionate about supply chain optimization with a specific field of interest in forecasting and inventory control. Mostly doing research from Slimstock for Slimstock. So yeah, that's a short introduction.
Perfect, thank you. And next we have Isik, who's a professor of supply chain management at Schulich School of Business. Isik, can you introduce yourself to the audience for a minute as well?
Thank you, Danny, for the introduction and for also having me here. And my name is Isik Bicer. I'm a professor at Schulich School of Business, York University. And for 18 years, I do research and also implemented some digital solutions for the companies as part of my research. And today I'm very happy to discuss some outcomes of my research and also to discuss some new developments in AI community which can have a potential to change the supply chains in general.
Thank you both. I'm looking forward to this a lot. So of course we've been on an AI hype train in the last few months. More about that later. I want to take a quick minute to introduce Slimstock for anyone who's not familiar with Slimstock, to give you an idea of what we do and why we're actually today talking about AI machine learning and supply chain planning. So Slimstock is a supply chain tech company, including implementation service, aftermarket consultancy in the field of supply chain planning. We specialize on forecasting, inventory management, assortment management, promotion, shelf life, sales and operations planning, product lifecycle management in multi-echelon networks, and basically the whole suite of planning as long as we're talking inventory. We provide solutions in several industries, going from retail to manufacturing, from fresh produce to critical spare parts. So anything you can imagine, I think, for companies that carry and have and sell inventory. We're a global company with local support. So we're headquartered, founded in the Netherlands in 1993. Currently, we have offices in over 25 countries and over 1,400 customers use our software globally. In North America specifically, we have offices in Toronto and Montreal and Chicago. We do over 150 new projects a year in the inventory optimization and sales and operations planning space. So that's a bit of the background of what Slimstock is, what Slimstock does, and of course, I think a lot of our suite and software, of course, we were implementing AI and machine learning, and Stephen will tell you a lot more about that. Now, let's dive into the content for today. I think over the last few months, we've seen AI and machine learning go through, I think, an almost excessive hype wave since the release of ChatGPT. It's often hailed as let's say the holy grail of supply chain. You know, this is finally the thing that's gonna solve all of our problems. Now, you know, is this just a hype? Will it fade away, or is there some truth to it being or making our lives substantially better, or drive better results for businesses? Is it something that can be truly valuable? So we're going to talk about and discuss AI in the context of supply chain planning. So really forecasting, network design, supply planning. And first order of business, we're going to talk about the differences in different types of AI. So, you know, what can a ChatGPT do? What's the outcome that we can get from ChatGPT? What are other models that might be better suited to help us? So, starting with you, Isik, can you really tell us a bit more about the three fields or different outcomes driven by AI solutions, the different outputs that we can expect from them? Basically, explain I think this graph was taken from your most recent book. You know, feel free to plug it a little bit to the audience if you want to, but yeah, tell us a bit more about the different types of AI that we see in
Thank you so much, Danny. But before starting, just to manage the expectations, so you talk about, you know, the practical, you know, sides and practical solutions of Slimstock. And meanwhile, I also want to look at the academic developments, and our participants will be interested in the academic developments. And my point here is that to better understand artificial intelligence, it's very important to take one step back and to look at the outputs of human intelligence. For example, as an output of our own intelligence, what do we produce? And then when we look at this, there are three dimensions of the outputs of the intelligence. Those are description, prediction, and decision. By the way, learning is a part of the intelligence, but it's not the output. Learning is a process that we learn something, but when it comes to produce an output as part of our intelligence, so that there are three important aspects, and those are description, prediction, and decision. And the description, for example, when we look at the K-12 education and elementary school education, and the students in classes, you know, they are often asked to read a chapter and then try and asked to explain things, certain issues with their own words. And for example, you know, they do that. And also in AI, in artificial intelligence, we have different tools to help companies to understand the certain circumstances, and also descriptive tools help the decision makers to identify some important business opportunities. And here there are three important aspects, so which is three important classes of the description part, and they are unsupervised learning, descriptive statistics, and some data management and visualization tools. And the important aspects of human intelligence when we look at the prediction. For example, on a windy day, when we look at, you know, from the window, and then we see that, you know, an apple may be shaking, and we can say that, okay, the apple on the tree would probably fall in 2 minutes. This is a prediction, and it's also output of human intelligence. And likewise, in AI ecosystem, and artificially we can develop some methods to make some predictions, and those are supervised learning, deep learning, learning and statistical learning techniques can be applied to develop some predictive models and to make some forecasts. And the last part is the decision, and this is part of the optimization and operations research. And for example, we as humans make some decisions, and they are different from the execution. Execution part may require some physical activity, but when it comes to make a decision, again, we humans use our intelligence to make the decisions. And in AI community, we have operation research and optimization tools which will help decision makers looking at some data and to optimize a certain decision variable. So if we look at these three dimensions separately, and there are very effective methods, and those effective methods can be used to make either description, prediction, or decision. But the most important innovation, some breakthrough innovations lie at the interfaces. For example, ChatGPT. ChatGPT is at the interface of description and prediction, because there are two different parts of ChatGPT. The first one is the prompt engineering. For example, we can have different wordings. We can ask the same question in different ways. For example, we may say that, how did the First World War start? Or what triggered the First World War? Or what are the reasons of First World War? But at the end, they are the same questions, but in a different way. So the prompt engineering first squeeze this information and then get a generic framework from our unique wordings. And that part is related to the unsupervised learning, especially principal component analysis used for that. And then after understanding the prompt, then ChatGPT, for example, utilizes a predictive model, and using the predictive model, it generates the outputs, and also it has an iterative process such that the output should not be distinguished from a human-generated output, so that it will be a breakthrough innovation that we use as a ChatGPT. And the second important part is that at the intersection of prediction and decision. For example, autonomous vehicles. And to use, to autonomous vehicles, and the lanes must be clear. So the structure must be clear. And the system doesn't have anything related to description, but it uses, the prediction models. For example, the car in front would probably change the lane, and then based on a predictive model, it predicts that. And after that, the autonomous vehicle makes a decision of either brakes or the gas pedal. And the last one is at the intersection of description and decision. And this is the digital twins. And in digital twins, the uncertainty is eliminated by some kind of simulations. And then in the digital twins, and first the objective is to develop a model which will replicate the real world situation, and then decision makers change, the decision parameters and to see the outcome, and it lies at the interface of decision and description.
Interesting. So I see there's, I think, a lot of promising and different types of outputs we generate through different AIs. I want to take this back to Steven. It's a little bit more, about those models in the context of the forecasting, supply planning. Where do those technologies sit on this chart? What are examples of some of these technologies?
Yeah, so maybe the first thing that I want to point out is that we as supply chain professionals, I think it's always the goal to find the best solution to a specific problem. And maybe machine learning is not always the best solution to a certain specific problem. So that's one thing to keep in mind as well. Now, I do think that, like you said in the beginning, it's very important that we look at what is the economic value of machine learning to supply chain planning. And if you look at these high impact problems where the underlying complexity is very large, there's the place that machine learning can help us. Now, if you look at description and prediction, I think most mature technologies that we use in supply chain planning at the moment, they lay in the prediction and description area. So in the supervised learning, the unsupervised learning, these kind of things. Now, for me personally, I think the most interesting area is the decision area. Because if you look at inventory control, it's well, it's kind of, we try to make decisions in a sequential nature, in the sense that every period we need to decide what to order and when are we going to order. So these are decisions that we make throughout time. Now, if technically what we can do in inventory control, if you look at most problems in inventory control, they can be modeled as what they call a certain Markov decision process. Now, that's a formal name, but informally it's kind of like an environment in which you may have to make the decisions. Now, reinforcement learning is one way of learning, just like supervised and unsupervised learning, and this is really suitable to solve these decision problems, these sequential decision problems. Now, the problem with reinforcement learning is the scalability. So if you look at decision problems and if you look at these environments, they can become very big very quickly, and that's when you can add deep learning techniques to cover that, and then you get these deep reinforcement learning techniques. And this is where I think the technology is not yet mature, especially not for supply chain planning. We still have problems with speed, with the high complexity of inventory systems. So we're not there yet, but I think that that's really a really interesting area to discover. Besides the already mature technologies like in prediction and description.
Thanks. Now, if you look at I think the last 2 months, and I already mentioned ChatGPT a couple of times, it's been making large waves. As it's probably the most discussed AI product to ever hit the market. I know it's determined. It's called a large language model, right? And I know, Isik, you already explained a little bit about where ChatGPT sits in this market. Is it something that's, these large language models, do we see any applicability in supply chain planning? Can we ask it, hey, ChatGPT, do my job for me today? Why not, or why do you actually think it going there?
Yeah, instead of just focusing on the functionality of the ChatGPT, and as you said, it's very important to look at where ChatGPT lies in this framework. It's at the intersection of description and prediction. So in past, we had a project as when I was in Switzerland, and there we utilized a similar technique, and which is which uses the principal component analysis. For example, just in supply chain management, think about the judgmental forecasting. So judgmental forecasting is used for new products. When a new product is in market, then we don't have any historical information about their demand, and it's very difficult to make a prediction, and there is too much uncertainty about those kind of new products. But at the same time, companies have large product categories, and for that product categories, they can, utilize some techniques to understand the similarity matches of this new product with the existing products, and then using, the historical information of these existing products, and they can come up with an effective predictive model. So for the judgmental forecasting, the position where ChatGPT lies can be very important for the forecasting tools, and for example, for the new product, and then using the principal component analysis and other unsupervised learning techniques. First, companies can put them in one category, depending on the uncertainty of the demand and depending on the seasonality, and they can, develop a similarity matrix from that, and then later they can utilize some econometrics tools to predict their future demand. So we did this in a project with a consumer packaged goods company, and we saw that it was very effective. And I totally agree with Steven, and because most of the important things for the supply chain management is at the decision part, because supply chains are always complex. Most of the time, it's just a mess. And then there are sequential decisions. For example, the decision that you make for the procurement will definitely impact, the product availability or component availability for the production schedule, so that we have this sequential nature, and the decision that the supply chain professionals make today will have a certain impact on their decisions for tomorrow and other days. So when we look at the decision, and then there are two intersections, and the first one is the intersection between prediction and decision. So in big data analytics, there are regularization methods, for example, and we can either use optimization models to improve the forecasting methods, or we can use the prediction models to improve the optimization tools. For example, in one of the projects, which is also a paper which I published at the HBR, and in my first book, I explained this in detail. And with Corsa, we had a regularization model, which is a tailored regularization, because the company operates in a B2B environment, and the customers are other companies, and they place bulky orders. And there are three types of the uncertainties. And when the companies have advanced order, advanced demand can serve in two ways. First, advanced demand is a predictor for the future total demand. And the other thing is that if we have an advanced demand, we are sure that the total demand will be more than the advanced demand. So at the same time, it's a constraint. So using, a constraint optimization integrated predictive model, then a forecasting tool can be developed, which will improve the forecast accuracy, and which lies at the intersection between prediction and decision. And the other one is in another project, which is with the GSK Biologicals, and there we utilize a Fourier transformation based optimization tool, and there we use a predictive model as a facilitator for the optimization model. And for GSK Biologicals, and they sell vaccines through tender process, and there is a there are some certain jumps in the demand process, so that we first try to predict the demand using the fast Fourier transformation, and apply the optimization model in the Fourier space to optimize the inventory decisions of that, so that the intersection at the intersection of prediction and decision, and there are several opportunities, and those opportunities can help supply chain decision makers. And but if we have a very complex supply chain structure, and then having an analytical model, even an approximate model or heuristic model, would be very difficult. And in certain cases, we may need to use digital twins. And digital twins are like Monte Carlo simulation. And first, we need to develop the model, which is casting a real world problem into a theoretical framework. And then using the simulation techniques, then we can understand the impact of some decisions on the bottom line. And the companies use that. And in one project, when I was in Netherlands, so we developed such a model with a master's student for a pharma company. And in that case, there were three classes of the customers, and some customers do not accept the products if the time to the due date, is less than 250 days, and the other customer is less sensitive. Let's say is 90 days, and one customer is 180 days. Although you sell the same product, and the time to the end of the shelf life is an important characteristic here, so that there is no analytical solution to solve, to optimize the inventory decision in that case. And definitely we need the digital twin, which the Monte Carlo simulation, and that was very helpful for the company.
Yeah. So if I going to think of my knowledge of digital twins, they're basically we test, okay, say this is our supply chain today, this could be our forecast, which could be based on one of those prediction models. But let's simulate what will happen if we configure our parameters or our supply chains different and see, okay, what does this actually mean for the cost of operating and running our business, right? Yes. That's the way we can utilize a prediction model in even, some of these digital twins as well.
Yes.
Yeah. I want to take it to the next topic in the interest of time. So we've seen applications of AI machine learning in supply chain, and I think we've seen some in academia, but we've also seen them make its way to practice. So Steven, I want to ask you a little bit about, okay, what are some of these successful applications of machine learning and AI that we've seen in the field? What advances are coming up in the future? So what are the most promising fields of research beyond that? So I'll let you explain that.
I think on the right side of the slide, you have the thing that I talked about a couple of minutes ago, the deep reinforcement learning area, which I think is very promiseful. We're still not, it's not yet mature in the supply chain planning world. A couple of months ago, Amazon did publish the paper called Deep Inventory Management. It was quite interesting in the sense that they kind of tried to apply deep reinforcement learning to approach a very complex problem. So I think we will see more and more of that, especially in academia. I've been to a conference last week. They are really, there's a lot of work done on improving the speed of these models. So speed is a significant problem. But if you look at the research that's being done, it's focused on parallelization. It's all about increasing the speed. So that's a really nice thing that they are doing right now. They're also looking at meta learning frameworks. So what you see is that machine learning methods are really good at doing one specific task. But because inventory control, supply chain, it's so complex, it's constantly changing. So you need kind of a meta learning framework to know when to apply which method. But if you look at things that we can actually do at the moment, there's already some nice applications that we can do. For example, anomaly detection is a technology that's very mature, the unsupervised learning way of doing it. So for example, if you look at forecasting, it's one of the most important steps before forecasting is making the data clean. And for that, for example, what we do is we look at the demand transactions from where the forecast is built, and we try to look at transactions that should be filtered out, and that seems to work very, very well. But also promotion forecasting. So if you look at forecasting technology or the machine learning technology, it can be superior to let's say simple statistical models, but somewhere where it really can thrive is promotion forecasting. I mean, promotions are not like a time series. It's really a really complex way of forecasting, because you have a lot of subtle patterns between these promotions, between these historical promotions. So this is something where we actually see that it works, but also new product introduction. And new product introduction is a way you can approach it in several ways. One way to approach it is to kind of look at unsupervised learning methods, where you kind of look at similar products that were already introduced in history to see what they have done. And then to combine kind of the demand that they have sold or the forecast that they have done. And then, of course, ChatGPT, so these large language models combined with these transformers. Well, I think it's very important.
You mean with transformers in this case?
Yeah, so if we were talking about large language models, but it's actually it's a combination between large language models and the transformer. That's a novel deep learning architecture that makes it so powerful. Now, I think it's very important to know what machine learning can do, but also what it cannot do. So the limitations to it. And for example, ChatGPT is it's for example not a calculating machine. So it's a word prediction machine. They call it stochastic parrots, which is I think a good phrasing of what it does. But it can help us immensely in things that we are doing. For example, what we see is that a lot of people have questions when they are navigating the software. And we have like a general help guide, let's say, but a way to naturally communicate with this help guide is really useful. But also communicating with the database. So, for example, if you want analytical insights, the thing that you have to do right now is you need to know how to get these insights from a database, and that's quite technically. ChatGPT allows us to naturally communicate with that database so that people can get insights like, what is my best product group, what is my service level on this group, all these kind of things. It's really easy to get this out of the database. So these are things that we are looking at and that we're working towards.
And I think the advantage here would be then that you don't need to know Excel or the tool itself. You don't have to know, okay, how do I sort, how I sum, how do I, all these technical skills. But we can ask it the question as we would ask a colleague or a peer, rather than actually learning the technical skills on how to do it.
Yeah.
I think we want to take that back because I think you gave another example earlier about, and that's where I think maybe some of the limitations lie. You talked about, when did World War I start, or when was World War I triggered? I guess for me that they're different questions, but they might have the same intent for an answer. They hope to get the same answer, but will they get the same answer? Is that one of the limitations of ChatGPT?
So I tried that. And at the end, more or less, definitely, verbally there were some differences, but ChatGPT returned almost the same answer. And here, when we look at, this slide, for example, outliers, and then when there's an outlier, it means that there is a huge uncertainty, which is in the system, and or promotion, forecasting, or new product introductions. And so those are some incidents which increases the variance in the system substantially. And ChatGPT can be very helpful to handle this type of. But again, we need to understand that in ChatGPT's potential is limited to description and prediction, not optimization of the decision. So as I said, and in the example which we did with the CPG company, and for the new product introductions, there's a judgmental forecasting process, and then ChatGPT can be used, to describe the characteristics of the new production and match with some existing ones, and then later the forecasting engine can be developed. Likewise, the promotion forecasting, when a company promotes a product and for some period, and then there is a big uncertainty in the system. And from supply chain perspective, sometimes especially those who support lean manufacturing practices, and they may say that, okay, if there's an uncertainty, let's eliminate that. But these kind of uncertainties can be a strategic uncertainty which cannot be eliminated in the system, so that companies need to find a way to manage it. And using the ChatGPT, for example, when a promotion will start, then ChatGPT can characterize the system, the potential impact of the promotion, and after that, still we need a forecasting tool to manage the things. And after that, when we move to the reinforcement learning, which is very important related to the structure of the supply chain as a system. Because in supply chain management, sometimes, decision makers just make a single replenishment, or they may look for an option for the second replenishment, multi-replenishment model, so that if such opportunities arise, then companies don't need to make the decision today. Today, they may order partially, and tomorrow they may place another order, and the other day, they may place another order. So the system, can be, the decisions can be just allocated over a certain time horizon, and then supply demand mismatches can be managed in a better way. So reinforcement learning has a big potential because it is related to the sequential decision-making problems. And then in sequential decision-making problems, when we make a decision today, we do not directly, have an objective function and optimize that. And in decision today, we also take into account the opportunity to make another decision or more than one decision in the coming days, so that we can make some adjustments, so that using reinforcement learning, I do believe that supply chain professionals can realize most of the potentials from the flexibility in supply.
Very, very interesting. Stephen, is there anything you want to add before we go to the next topic? No?
No.
Okay. So what I want to discuss now is I think I think there's, if we talk forecasting specifically, which I think both in academia and practice sees, I think there's quite a lot of attention on the forecasting side of things. So the holy grail of forecasting, it's seen pretty wide and large application of machine learning techniques. A lot of media, marketing, establishing AI forecasting as a solution for some of the big problems we've seen in supply chain. So we've gone through COVID, we've gone through Suez Canal blockages. I think one specifically in Canada, we had a shortage of, I think, aspirin and medication for children specifically. And I want to talk about AI in the context of this kind of supply chain planning, and is better forecasting really a solution for we're looking for here. And Isik, can you talk a little bit, a quick comment on the context of AI models and how they're limited or strengthened by good supply chain design?
So definitely supply chain design is very important. And if decision makers do not have the flexibility to make sequential decisions, for example, and there is no need to develop a reinforcement learning, and then a simple optimization model can work in that case. So that supply chain design gives us, the certain, structure, and which is the state, and based on that state, the AI models can be implemented, and then a suitable AI model can be developed, so that we can see, in different settings, some complex supply chain models or some simple supply chain models. And it's very important, to position supply chains in the companies, in organizations, or in the economic systems as well.
Yeah. And Stephen, so I think we just talked about a lot of different techniques of machine learning AI. We mentioned digital twins. So we discussed this in the application of a traditional supply chain. Where do they really sit in the context of the supply chain that we see here? And what sort of techniques can help us prevent, larger market shortages if we look back at some of the earlier topics we discussed?
Yeah, so I heard you talk about, I think we need to nuance the whole AI is the holy grail for forecasting a bit. I mean, personally, I acknowledge the possibility of machine learning to be superior to statistical models, because from a theoretical perspective, it's only natural. I mean, forecasting is a game of describing demand with the correct number of parameters to distinguish patterns from noise. And I think the underlying algorithmic design of machine learning can exactly do that. But there are also a lot of conditions. And that also depends. I mean, if we want to place it in supply chain and supply chain designs, we already talked about some conditions to get it right. Like for example, if you look at data collection, if you look at the technologies that's being developed based on data, there's kind of a unlimited resource of data online, for example. But that's not the case if you look at traditional supply chain. Traditional supply chains are based on how much you sell. If you can sell something, you have data. So it's also about a little bit how big are you as a company. For example, Amazon, they are working on such a large scale, so they also have a lot more data. If you look at smaller companies, well, the problem with smaller companies will be that at a certain point, these Amazon giants, they will get more and more data, they will get bigger and bigger, and these smaller companies, they will lag behind. So at a certain point, you will have to think about how we're going to collect data over companies, so between companies, doing this in a secure way. But I think maybe it's the biggest problem with machine learning is not the conditions or the way to get it in supply chain. I think it's again another thing to kind of cover up what our supply chain design is lacking. And with that I mean uncertainty, demand uncertainty. So we're always trying to minimize demand uncertainty by better forecasting and stuff like that. But if you look at why do we have that uncertainty, that's another question to ask. And maybe that's something that we should look at, especially in supply chains, is to look at trying to mitigate the uncertainty by better communication with our customers, increasing information by looking at sales and stuff like that. And I think that's something that we shouldn't lose sight of if we're talking about machine learning and supply chain designs. So yeah, but also if you look at, for example, machine learning, the thing with machine learning is that it's really how do you say, it's really sensitive to certain input variables. So what we saw, what you see from research is that they can be quite nervous, they can be quite chaotic in their outcomes. And if you look at supply chains, chaotic or chaos is the one thing that we definitely not need. So if you look at these applications of machine learning and you look at the supply chain cost, at the total cost, you often see that machine learning still needs some robustness to be really valuable to the entire supply chain. So that's something to take in mind, I think.
So if you would take an example here, so we would have a case where we see the demand for, let's say, aspirin or ibuprofen spike because there's a flu epidemic going on. Now, machine learning would be able to detect that. I would say rather than just using your inside out historical sales data, because obviously that flu epidemic is not in your data, or it was, but it was at another random point in time. So it can help us predict that better. But I think when we talk about supply chain design, if our supply chain is not able to deal with that spike, we're still going to see shortages, right? I think that's where, and that's where I think some of the other techniques that can help us design a supply chain to deal with these events that we build in, the slack capacity, that we really make our supply chains truly agile to move quicker than they would typically move.
Yeah, I think, I mean, it's kind of a philosophical question to try to answer. Can we predict everything? So
yeah, no, exactly. Yeah.
I mean, the deeper you look into the data, the more patterns you will find. But how far can you look into the data? So that's a difficult question. I mean, there will always be shortages because I mean, for demand uncertainty, the thing that we're trying to solve with forecasting, that's not the biggest problem we have in supply chains. If you look at the supply side, the lead time uncertainty, that's a much bigger component in our uncertainty. And So and then you get that vicious circle in the sense that if we cannot predict everything, that will create shortages. Shortages will always be a main source of lead time uncertainty. That will again increase shortages. So you will get that kind of paradox that you will never come out. So
Yeah,
I mean that sounds really pessimistic, but it's also I mean it's challenging.
it is, yes. But it's that's what we're in it for. I think that's what we need to realize, right? It's not a blank AI and machine learning. It's not a blanket solution. There's still problems will always be there. But no, I think one of my prime examples is always I don't even know what I'm going to eat for dinner tonight. So like, how can someone predict what I'm going to buy? So as long as we cannot make up our minds, forecasting will never be perfect. I want to take it to the last topic of today, and I want to remind the audience, if you have any questions, please submit them via the questions or chat tool to us, and we'll get to them at the end of this panel. We're on to the last topic, so please start submitting your questions right now. Last thing I want to talk about is the conditions to start with AI machine learning. What does that look like? And Isik, I want to start with you. What are some of these necessary conditions and things we need to have in place to start with this?
So there are indeed two important things. The first one is the digital maturity of a company. And companies, collect data from different sources, and data can be primary or secondary data. And then this data, should be stored in the database. And after that, through some workflows and pipelines, and data is transferred to the data lakes. And after that, data scientists and developers develop some analytical tools. They can be descriptive tools such that decision makers or senior executives get some dashboards, which will facilitate their strategic plans as well, because as we know, supply and demand plans are also used for strategic plans to forecast the revenues and costs. Or there may be some other applications for order management, sales and fulfillment management, inventory management, and then those applications should be developed by data scientists with the help of software developers. So data maturity is one part. And while listening to Steven, so I do agree that supply chain professionals in some sense are philosophers, because and it's also related to the infrastructure and of the supply chain networks, because when we just think about the definition of supply chain management, for example, some people define supply chain management as the practice of having the right product at the right time in the right place to fulfill customer demand without having excess inventory. And in some cases, supply chain management is described as the coordination of information, operational and capital flows. And according to World Economic Forum, supply chain management is defined as the backbone of economic systems. So when we look at these definitions, there are not only verbal differences. These definitions are structurally different. I mean, there is too much ambiguity even for a simple thing related to the definition of supply chain management. But when we look at the finance, accounting, we know that there are some accounting principles, some standards, and they are, common and standard everywhere. So that the question here is not the definition of supply chain management or the right infrastructure of supply chain management, because the infrastructure or data infrastructure and supply chain design, they all differ. And they all different. But when we look at the causes of this ambiguity, maybe the right question as an academic must be, why is there so much ambiguity, even for a simple thing related to the definition of supply chain management? So when we look at the economical developments, for example, for the liberal systems, supply chain management was first defined, considered as part of the markets. But since markets are not efficient because of the inefficiency, then the new economic developments, economic theories, they place supply chain management to the production and considering them as a factor of production. And now when we look at the supply chain management, they are confined, squeezed between markets and the production, so that there are so many, sources of the mass and ambiguities, and then supply chain management is probably the most difficult part for managing the businesses. So that, and then we need to understand how we position supply chains. Are supply chains part of the markets so that we can focus on the fulfillment strategies, or supply chains part of the manufacturing so that we can focus on the procurement and production? And this will allow us to develop the right machine learning, right AI models. For example, when we go to a luxury brand, for luxury brand, the tools to optimize the inventory decision, they do not care much about that. For them, supply chain transparency, circularity, and the blockchain technologies are the most important applications. Or when we go to, some innovative companies like Starbucks, and they are innovating the business processes so that Starbucks, for example, now they generate 20% of the profits from non-operational activities, especially through app, and they collect money, and then now there is more than $1.5 billion, in Starbucks app uploaded by the customers, so that they consider supply chain as a facilitator, so that the customers upload money there. And for Starbucks, the priorities of supply chain management is different. And when we go to fast fashion, and when we go to automobile companies where they use supply chain integration or lean manufacturing, again, the priorities are different. And for these types of priorities, and definitely the AI models and machine learning models totally differ.
So I think what you're trying to get at is, we of course have to look at the value proposition or the value chain of the company and say, not everything is a cost trade-off, right? Because I think that's, maybe we define machine learning as being a cost trade-off, but there's pieces in the cost trade-off that machine learning might not know of. I think you're seeing, if you see Starbucks as a bank, there's the money you make on the cash to cash cycle, there's the money you make on the product. So if we only optimize the product, we get a different result on our cash to cash cycle, which might actually be not beneficial. That's very, very interesting. We only have a few minutes left, so I have to cut you short a little bit and give an opportunity to Stephen for, I think, the last bit. So I know at Slimstock we're implementing a lot of these techniques. We make these applicable to thousands of customers in all sorts of industries. What are really the challenges in building machine learning models for a variety of industries and the position in the supply chain that they're in?
Yeah, I mean, I think it's a big challenge. So we started a couple of years ago, well, many years ago. I also want to give some credit to the entire research team at Slimstock for setting these things up, because it was kind of an entire new paradigm that we're trying to add at our software. And the challenge, I mean, machine learning is not challenging because of the models. It's challenging because of the data processing that we have to do. So think about the speed that it needs to do all these kind of things, the memory consumption, all of these kind of things. From a software engineering perspective, it's a very challenging thing, but also from a business perspective. But what we're trying to do as a software company is we want to standardize as much as possible, but you shouldn't standardize everything. I mean, users still have to be in control, or still have they have to have the feeling to be that they are in control.
So that's actually, I think, what Isik was just mentioning, right? Like there's still things we cannot quantify.
Exactly. And I mean, what we saw in implementing these kind of things is what works well is that we think about how are we going to process the data, what kind of features are we going to engineer, what kind of features do we allow users to choose from, but also look or trying to implement machine learning from what they call a humble AI perspective, in the sense that everything that comes out of the machine, we know not every answer will be from a high quality. So we have to acknowledge that. We have to know when is an answer going to be of high quality and when not, and can we give that feedback to the customer, to the user, so that they know, okay, this model is perhaps not trained well enough, we didn't have enough data, but also like we saw the accuracy on test batches, and we saw that the accuracy of this model wasn't that good, so be careful. Or for example, if we miss certain features that have a high predictive value, we know that the answer will not be of a high quality. So these are things that you have to try to get to the user, so that that connection between the software and the user is always optimal.
Yeah, thanks. I want to take it to the questions that people have. There's quite a few. I'm just gonna stick with two of them, and you can push forward some of the questions to the participants later. First one I have is actually for you, Isik, and a question about the interaction that's taking place between industry and academia. So how do you prepare your graduates for this kind of machine learning and AI world? What's your position on that?
So as a researcher, my job, part of my job, is to go to the industry and to understand their problems, and after that, shape, my research direction, and then after, understanding the problems in the industry, and then developing some research methods, and then the next thing is to share this information with our students, so that students will be ready for a new career to apply AI methods to solve complex supply chain problems. And because of my research, I'm interested in uncertainty modeling part. So that it's not only giving students a bunch of methods, just equipping them with some analytical methods, so that we also want them to understand some the role of structural thinking to solve supply chain management problems, because supply chains are very complex, and because of the complexity, it's very important to focus on the smaller parts and then aggregate those issues together to have a complete solution. And what uncertainty modeling does is very important in that sense, because, for example, think about a facility which produces goods for the North American market, and then there are 3 different states, and that the company is very active, and in those states the demand may have different structures. In one of them, the company may be selling through wholesalers. In one, company may be selling directly to the customers through online channels, and the other one, through some stores. And then there may be some different characteristics in the sales channels. And because of that characteristic, because of this difference in the characteristics of the channels, the company may be exposed to different types of demand uncertainties. In one market, the statistical distribution would be relevant. In another market, the product may not be selling well and only a limited empirical data. In the other one, there may be a stochastic distribution. So if we focus separately to the markets, then we can develop a good understanding about the uncertainty. But for the central facility, we need an aggregate model. How do we aggregate these uncertainties so that we can come up with a inventory policy which will be applied to fulfill the demand in all different markets? And the fast Fourier transform is one of the most interesting things to solve that type of problem. And according to MIT Technology Review, and they select 10 most important, most innovative things which will change the world. And fast Fourier transform, it is used in cryptography and for blockchain technologies for hashing, and also for the optimization models. I'm using it in my research, so that I also teach it in classroom so that students at least at some point, can develop some simple, models so that they can apply this type of solutions to solve the supply chain problem. So that in academia, we are not isolated from the industry, and then we are motivated by the industrial problems to have a good research direction, practical and relevant, and also to train the leaders in the future in supply chain practices.
Yeah. Thanks. Stephen, I want to ask you to comment on the same question. We're 2 minutes over time, so I want to ask you to keep it short before we call it a day. Like, what's your vision on how academia and I think, what we do in practice really complement each other?
Yeah, I think we both have a specific role. I mean, academia, they have to look at, and that's also what Isik said, like look at the questions in practice that are really valuable to solve, and not like what they call incremental research to make every thing slightly better. No, we have to look at these high impact problems that can really benefit practice, and in practice we have to kind of embrace and kind of get to know these things from academia, because the nice thing about theory and academia is that they think rationally about problems, so they tell you to act optimally, and that doesn't mean that you can actually act optimally. I mean, there will always be some deviations, but it will tell you where the optimal behavior is, and it tells you something about how to think about things and about how to reason about things. So this is very important that we constantly have that interaction between academia and practice, because I still think that the gap between theory and practice is a bit too large. But that's something that we can easily solve.
Yeah, we just need to work together to get better models. I want to thank the both of you for being here today. I learned a lot myself, so thanks for that. I want to thank the audience for being here with us today. And if you have any further questions, don't hesitate to reach out on LinkedIn or just reply to the email. Everyone should get a copy of the slide deck after this session. And if you have any more questions, just send us a note. I'm pretty sure everyone is happy to answer any additional questions that you have. So thanks everyone. Have a good day, and thanks again, Stephen and Isik, for your very valuable inputs today. Thanks.
Take care. Thank you, Isik. Cheers, guys. Bye.
Bye.